Hi, I'm Shadi Ashnai. We recently changed the name of the team to Sound and Vision. I think it sounds a bit better than the image processing because we grew so much out of just image processing. I've been giving these series of what's new in image and audio talks for the past 3-4 years, but honestly, there is so much happening in these domains that it's hard to show all of them in one half-an-hour talk. There are so many other talks. Some of them have happened. Some of them are happening today. A lot of them are happening after this. I'll give pointers so that you make sure if you're interested in the topic, you do go to the other talks as well. I'm gonna, in this talk, I'm gonna show a little bit of audio because I wasn't sure all of you have made it to previous talk, which Piotr gave on import-export of audio, and another one that is later this afternoon at 3:30 on processing and analysis. So I'll show a little bit of that. It's still the introduction. We are putting it in our talks mainly to show you what's coming and mainly to get feedback. That's always one of the very important aspects of tech conference, so that we put up content that is under development to get feedback. So please, while you're still around, we are still around, give us feedback. There's been tremendous updates on audio and image analysis, a lot of focus on machine learning neural net integration and applications that are possible with the combination. We have had some special focuses like speech and speaker analysis in the audio side, face and textual image understanding in the image side. Once those are wrapped up, there are other application domains that we're going to go into. While working on those, talking about how do we embed findings from images, audio, and now video into those objects to use them later, has brought up this idea of annotations for different objects in the image. For some of you who have been in the discussions, live stream, design reviews, and so forth, you may have heard of it. It's not a clear path for us at this point, where we're going, what we're doing. Another point that I put it up there, but it's not really a feature we are featuring. We are hiding it as much as we can as developers. But any feedback is going to be useful so that we can finalize those designs and really know or get to the point that what's going to be useful to have. Let's start with the most exciting thing, which is the video, which combines so many frames of images that we have handled since version 7 and audio, which we started handling since version 11. We are expanding the number of formats that we are supporting so that with the old functionality of import and export, that you could get video frames, frame by frame, and metadata and so forth, you can now get it for many more formats. And as Piotr was just showing next door, there are a lot of codecs that we are supporting. FFmpeg is the backend. We're also utilizing operating systems on Mac and Windows both. So we are really trying to support many file formats and many codecs. A lot of them that you can now import and process in Mathematica. The default player on your operating system may choke on playing. We're hoping we're going to be the hub that can really handle any type of video codec. And then as well, similar to these variables that are coming, $video decoders, there is $video encoders for export, and there is also audio and subtitles decoders and encoders, which is giving you the full scope of things that are going to be supported on your platform, on your machine, because it's going to be platform dependent. So video is a new head. There is going to be an object that contains all of this information, image data, audio data, and metadata in one place. The player that we are showing at this conference is just a prototype. This is a cute 1.5-minute video that Steven didn't click the play on at the keynote, and Piotr, I think, didn't have time to show it. I can just pause and show it. It's a cute thing, ends at the end. Nice, let me see. The GUI still, yeah, okay. So while the pool thing tries to cross the road, the video object is all out of core. So we don't really care how large is the resolution of each frame or how long the video object is. It can live happily in a notebook and play. The GUI is not as smooth as we would like it to be now because all the data is being imported into the kernel and sent back to the front end to be displayed. And so for that matter, high resolution videos at high frame rate will be laggy. So if we release this in 12.1, know that this is laggy, but we know it's laggy. It's not gonna stay like that. We're working with the front-end team to have proper library link support in the front-end. This is driving the library link support front-end, the library link support in the front-end. There's going to be a lot of other applications of library link in the front-end that is going to benefit from that as well. Okay, the thing didn't die. The first thing I asked Piotr when he showed me that video is it going to survive after a minute and a half? He said yes. Anyways, the head of this object is video. This is now common paradigm from the objects that we have introduced. There's a video queue which returns true if everything is all right. Information is going to return some information like how many tracks of video, how many tracks of audio, how many tracks of subtitle. We are currently supporting any video with any number of tracks for any of those three. Which is complicating import-export a little bit, so you have to actually know which track you want to access. If it's a single track thing, it might be annoying. Piotr was just talking about that next door. Feedback on that would be valuable for us at this point. Similarly to audio stream, if you have played with that, we have a video stream. I really don't need to show the player again, unless you want to see the thing again. Video stream is an object that is basically a handle to a specific position of the video object at a given time. So I can create dynamic of position and current image and then call video play, again, very similar to audio play. This is a dynamic of current frame. The audio plays through the sound card and the position is changing as we go. Not to bore you with the same thing again, my daughters wouldn't mind seeing it again. So that's a way of programmatically start, stop, change position in time and get other properties from it. We believe it's going to be useful. This is the backend for our GUI. And then these stream objects are going to enable you or any user to create whatever GUI they would like to create. There is some minimal analysis coming in 12.1. Obviously, more is planned. This is something similar to what Steven showed as well at the keynote. Video map is one of the functions that get a single frame at a time, runs any image operation on it, returns the result as one sample in the time series. So a time series comes back. This is a single value per frame. We get a single value plot. This other one is, this video block map is another analysis function which gets a buffer of images at a time, returns one result. So in this point, I'm getting 2 frames, moving the buffer by 1 frame, computing image distance on those 2 frames, which is basically telling me how different 1 frame is from the next one. The plot that I'm getting, the peaks are basically saying that at some points in time, basically the scene changed or something significant happened in the video. So that's kind of a scene change. And you can imagine any tracking algorithm or anything that requires more than 1 frame at a time is going to be handled through that. Other than just getting frames in and returning some analysis back, we can also get frames in, process them, put them back. So the 2 functions that we currently have in prototype builds that we are developing are video apply and video filter. Video apply is a single image in, single image out. So in this case, I'm just running a color negate. The result is basically a negated version of that video frame by frame. Good for Halloween, I suppose. Sorry? Yeah, looks like a new video. And then obviously for us to be able to have those processing capabilities, we needed to have export to make all of this happen. Not that export of video is not useful otherwise anyways. There's some new formats that are being supported by export, and obviously again a whole lot of encoders. On top of that, what we're getting, which is not specifically video processing or video analysis, is all of the manipulate exports and other types of exports to video hopefully is going to be coming with or without sound. Again, Piotr just showed that next door, just in case you missed that. Here I have a manipulate, and then I'm exporting it. Oh, I didn't plan to run any of that. I just already have those. Oh yeah, I killed that one, sorry. This is another one that I'm exporting and manipulate with an audio. Let me check. This is the other talk. Oh, okay. Let me see. This is something I generated, sorry, it was just in a different location. So I exported the manipulate with a sound object or an audio object at the same time to a new video file from Mathematica. So I just changed that directory, it's gonna work. So as I said, Piotr talked about import-export before this, the recordings should be available. Chenyu and I are talking more about video and basically showing a few more of the application examples that we could put together for now to show what may be possible in the future. Any feedback on any of that would be greatly valuable. Audio updates. There has been, as I said, a great push for having neural nets and machine learning tight integration with all of the audio applications that we have. When we released 12, we thought it's justifiable to have separate product pages for machine learning for audio and images. I didn't repeat these examples in the talk, but a very typical application example is that you have a specific set of audio samples, or in the case of image samples, that you would like to classify. There are not the notable people that we already have a built-in classifier. They are not types of objects that we have classified image identify for. There might be things like animal sounds that you just happen to have a data set for and you want to classify them. So these examples are, I think, great starters for anyone who wants to see what is possible to be done with our system using all the great machine learning capabilities that we have in and all the built-in audio processing capabilities that we have. This example goes, grabs a bunch of samples of different types of animals and then runs a classifier and is doing a fine job. So for any types of audio sample that you have, these are the kinds of example that you would like to get. Small but important, audio wasn't supported in the cloud for various reasons. It took us longer than it should have, but if you were upset with the fact that audio weren't playing in the cloud, it does now since a couple of months ago. So small but important. There are some audio streaming updates coming. I'm not showing any examples because they weren't working in my build. But the importance of the first one that I have there, we're introducing infinite generators for audio streams via this same audio stream construct that we have had before, but we just feed it a function that can infinitely generate samples for a streaming audio, infinitely. I think this is a good practice for us to next look at podcasts, live streams of audio, maybe live stream of video. We were talking about IP cameras earlier in this conference. So all of those are practices that we are step by step trying to build into the system and see where we're going next. Another idea that is cooking is collection of these things. How do we want collections of audio to be treated in our system, basically? If you have a list, do you want them to synchronously play at the same time in parallel? Do you want them to be a sequence of audio that you play one after each other? And then if you want to seek from, in a collection of audio samples, how do you jump from one sample to the next? Or how do you jump to 10th minute of that collection of audio, regardless of how many they are and how long each one of them are? So these two are basically, as I said, just practices that we're doing to see what kinds of applications these are going to enable. I don't know, combining a generated stream with an existing file, streaming it eventually out to the world, exporting them. So there are just so many things, so many ideas that are cooking. Any feedback is greatly valuable on those as well. Audio stream can currently generate finite audio from a time series, and that was already released in 11.2 or 3, I think. That's there, but anything else that is not, we're interested in knowing what are the needs out there, what kind of connection we can discuss maybe after.
So if you infinitely stream, you need to generate samples in time. So
Right, right. The argument of that function is going to be time.
And then how will you guard against a sample's not ready, or will you just stop streaming, or what are your thoughts?
If the generation process takes longer,
Yeah, it can't keep up.
we haven't played with that yet. Good practice to do. Can we record a generated stream, Carla? Yeah. And can that wait for the samples to? Okay, but I think it would be a good practice for us to add utilities for the process to either wait or have some default values to fill in or something like that. I guess all of those are viable solutions. There is a whole talk about speech. I'm not going to spoil the next talk that Carla and Rebecca are giving. Just a quick snippet, because I know this is a lot of talks going on, so I'm not sure if everybody's going to make it to the next talk. Speech recognized was a valuable addition. On top of that, we expanded or combined speech recognition with interpreter and text cases. So here I have a sample.
1.
That said 1. This was not very loud. If I run speech interpreter on that audio sample for a class like semantic number, I get the recognition, I get the interpretation of that speech signal back in the system. So you can imagine this is going to be very useful for spoken forms, so that you hit on the microphone, you record something quick, and then interpretation of that comes back. This is another recording of a date.
Next Tuesday.
I may have to increase the volume. So this said next Tuesday. I think this is an interpreter problem in the recent builds that we have. Italy. Let's see if interpreter can interpret that. So similar to that, we combined. So we have a good phrase. You use prototype, latest prototype, nightly prototype builds, you get everything, but then you do get everything, including the bugs.
New York is the most populous city in the United States of America.
So this is a recording, and we ask for speech cases that are words, so we get that back. Then this is the same recording, I believe. I don't play that again. We get cities and countries back. I don't run the interpreter again for this one. Notable speaker classifier is coming, similar to notable person classifier. I just go a bit faster so that I don't run out of time, but this is nice and easy. Speaker feature extraction is going to be useful to doing any speaker analysis. Again, Carlo is showing it right after this, or in half an hour after this. I think I'm just going to run out of time. I can try. Let's see. This is getting a bunch of samples from resource data. Well, maybe not that bad. The samples look like a recording like that. They have a speaker ID, and then they have the ground truth of what that class is. Instead of trying to classify for the numbers, for the digits, to do the actual digit classification, we are using this network, which is basically trying to separate speakers, not the spoken word, not the numbers, the speaker. And the output of that net is basically a feature vector like that. If I space plot, feature space plot, all of the vectors that I get back for the samples from that spoken digit data set, instead of getting a bunch of 1s and 2s and 3s and 4s, I'm supposed to get back a bunch of speakers, which are denoted by these unique IDs attached to each speaker. And you can see that each speaker is clustered into a separate location. Again, more of this is coming in the next talk, more in depth, more details. Make sure if you're interested in that, you don't miss it. Speech synthesis very quickly. We are trying to hook up to services so that higher quality speech synthesis is coming, hopefully next release. And then SSML is a symbolic representation of speech. We are looking into that as well. A lot of updates for image processing. Again, a quick jump to the product page that we created. A lot of very practical hands-on application like this one, which is using the image identification nets to classify something else that is unseen to our system before. There are a lot of little utilities. I always like to talk about them because this is development time and it's valuable. Image assemble was one very simple function, for instance. This is just a sample of all the things, which couldn't handle assembling a bunch of images that had different properties like different sizes here. We put some minimal development time into trying to make this kind of a thing possible so that you don't have to worry about what's the size, what are the color spaces, what are the bit depths and things like that of images. And then one, fairly useful application of things like that is that you do some kind of a processing on an image and you want to show it in a grid, for instance, in this case. It's just becoming easier. So a lot of what Steven calls LCC and ILD is really happening. The language consistency and incremental development is happening in all corners of the language. Another fairly important one, spatial transforms. Everything speed is becoming important for us, especially with upcoming video. So something as simple like that, where we're doing a transformation, wasn't fast enough. So we put some development time into improving speed of that. So it's, again, just a sample of so many of similar kinds of developments that we are doing, which is not necessarily highlighted in our releases, but eventually becomes very important. So this is an example Marcus showed a couple of years back, which is getting a bunch of points on an image and doing a thin plate spline transform. It wasn't as responsive. This is live transform. You just get some control points and move them around as fast, as quick. It's easy to miss them in the releases, but they're all very valuable, very important. Highlight image is updating. Instead of red, it's returning magenta highlights now, which is important because when you had, a lot of times it was confused with the pink boxing we got that feedback enough. But more than the color change, there are labeling and legending that are coming, which is also lines up with the annotation problems that we are trying to solve. When you have labeled regions that you would like to highlight, it would be nice, and we're working on making that even better, to have the labels in place or have them on the side as a legend or have them both. Image toolbar has been there for a while. I don't show this, just skip it. We are thinking about doing updates, including making some kind of an interactive annotation potentially, if that becomes a real thing. Specifically, as I said, we focused on facial and textual image analysis in the recent releases. We had face detection before. We're adding face alignment, which is very crucial for any face recognition application that's coming. And then just to highlight the fact that highlighting is important, that these are approximate ages for the faces that were detected. It is nice to have them all in one place. Text analysis has been there for a while. It still has a lot of room for improvement. One new thing that is coming is text detection, which as well is going to be discussed next in the talk by Julio and Mikhail. So you now can get bounding boxes, rotated or not, on images that have text. This is going to work for natural as well as scanned images like that. And then you can split the words that are detected by character, word, lines, and so forth. All good utilities that have very broad range of applications. There is a MOOC coming up for image processing. This is, I think, is going to get released in the next week or two. It's a basic course, but it's, I think, a very good entry point for anyone who has missed the image processing class or never touched the topics but wants to step in and learn about it. So I thought I would mention that in case you have anyone who may have interest. Annotations. We had released audio annotations in, I think, 12, but we really kept it quiet, maybe one example in the product page. I have a second left. I just show the kinds of things. For instance, in this example, we annotated all the loud parts of a signal, and we have a way of displaying them. It sticks to the audio object. When it comes to export, there's not really a good container other than maybe putting it in an XML file next to the audio file. Similar things are going to be coming for image annotations. If I can, okay. So similar bounding boxes of objects that we have detected or ages corresponding to people detected, all of those I think would be nice to store next to the image as long as the image is in our system. But then when it comes to export, again, typically no format nicely supports any of that. A lot of import-export updates in the image audio domain to make sure things are robust and as fast as possible. The high-efficiency format has been a request for a while that's coming. DICOM-dir for those in medical fields has been requested, and a lot of more efficiency updates. Again, there have been talks on specifically on import-export, but as well on library link utilities, which is a product of our development in our team because we rely on low-level libraries and we rely on efficiency. So watch out for that as well, which is being released on GitHub hopefully soon. Thanks.